On today's Visual Studio Toolbox, we kick off a three-part mini-series on machine learning. Veronika is going to give us a nice high-level overview. Hi, welcome to Visual Studio Toolbox. I'm your host, Robert Green, and joining me today is Veronika Kolesnikova. Hi, Veronika. How are you?
Hi, Robert. Good to see you.
Thanks for coming on the show.
Thanks for inviting me. I'm so excited to be here.
And what we're going to do is, this is the first of a three-parter, at least that's the plan right now, a three-parter on machine learning and ML.net. This is something that we've covered a couple times before, but I thought we'd take an opportunity to kind of start from scratch, introduce it. What is it? How does it work? How can you take advantage of it as developers? And spend a little bit of time. So we'll do 3 episodes. The first is going to be an introduction, kind of an overview. Then we're going to start building in the next episode, which will be next week. We'll start building a model and see what the coding looks like and what it does. And then in the third episode, maybe some more advanced topics. And that should get the conversation started. Sound good?
Yeah, perfect.
All right. Go.
Hi, everyone. I would like to share my screen and start talking about ML.net, artificial intelligence, and all that fun stuff. And we'll start with just general overview of artificial intelligence and machine learning. I know it's really popular right now. Artificial intelligence is everywhere. Everyone is talking about how it's important. They use it in different applications. But I would like to talk about artificial intelligence and machine learning together, how they related, how they maybe working together, maybe not working together. So let's start. And I'll start with the first part here, and it is artificial intelligence. So artificial intelligence has so many different definitions, but in general, it's something that we as humans are good at, but machines are not. So we are trying to mimic human logic is using if-then rules and decision trees and some specific techniques, again, to just mimic how our human thought process is working. And then a subset of artificial intelligence is machine learning. And machine learning is basically a combination of statistics and algorithms. The algorithms that I mentioned before, like if-then rules and similar items. And also, for machine learning, we are getting a lot of data and we are trying to process the data and make use of it.
So machine learning would be how Amazon or Netflix watches me and then can predict what I might want to do, right? So if I look at particular books over and over again, it will then suggest particular books. Or if I watch particular shows, it will suggest similar shows. That's kind of machine learning, right?
Yes,
is that true?
Exactly.
Yeah.
Yep.
And then artificial intelligence would be self-driving cars, right? That's at a higher level, which obviously use a lot of machine learning in them to figure out what to do. But it's really more the algorithms that we know and love are machine learning, right?
Yes.
Okay.
And machine learning is a subset of the bigger artificial intelligence category. And I think you provided a perfect example here of self-driving cars as artificial intelligence.
Cool.
So next subset here is deep learning. That's a subset of machine learning. So when we get a lot of data, we want to use it in the most efficient way. So we want to create multi-layered neural networks. So our software or hardware or whatever tools are using our deep learning models, they can be efficient, and also they can perform more complex tasks like image recognition, video analyzing. And if you worked with Microsoft Cognitive Services, or at least you heard about them, then all of them are based on those deep learning techniques.
Okay.
So when we start working with machine learning techniques and different tools that are available right there, out there for all of us developers, data scientists, and all kinds of specialists, because now there's so many different tools that you don't have to have a specific background or specific knowledge in data science, have a PhD degree, but what is important to know is machine learning is not just a magic box where you can put all your data and then suddenly it will provide you a great machine learning model that will be efficient and will perform well, provide accurate results. Unfortunately, that's not how it works. And I have an example that I really like to mention in my presentations. It's that bot that Microsoft had probably several years ago called Tay. It was released on on Twitter, and it was just floating there, consuming all the data from all the tweets, and then within, I think, a couple of hours, the bot actually became really racist, rude, and absolutely horrible. It posted horrible things, so Microsoft had to put it down and remove it completely from Twitter. But for Microsoft and all of us, it's a really good example that you shouldn't just let your machine learning model learn free from everywhere, especially from Twitter. And related to that, I have that slide for data preparation. So you need to make sure that your data is clean, it is all filtered out, and it is ready to be fed to a machine learning model, to specific tools. There are
So this is
also
data that you're going to use to train and then continuously improve your model, right?
Yeah, so you have that initial dump of data to actually create your model. And then later on, as you see that something maybe is not working correctly, maybe it's not um, performing up to your standards, there are some errors happening, or it doesn't, if it's an image recognition model, then it doesn't recognize the objects correctly, then you can actually provide more data and then retrain it and make sure that it's working correctly.
On
And
average, how long does it take? Maybe it's a hard question to answer, but how long have you seen it take from the initial data set to the initial model to something that you're actually happy with, that actually works and is the model you really want? Is that weeks, months, years?
I know that maybe several years ago it could take years because of the tools. It was just the beginning of that machine learning era. I know machine learning has been around for quite some time. I remember I had a class related to machine learning in my undergrad, but at that time, it wasn't popular, so I didn't pay a lot of attention to it, unfortunately. I regretted it later, several years later. But going back to your question, it depends. Now, with the amount of tools that are out there, the amount of pre-built models that you can just reuse with your custom data.
Mhm.
Um, the process is getting faster and faster. For example, if you are using AutoML or going back to cognitive services, it can take just a couple of minutes to just you basically provide your custom data there, and
Mhm.
then you are retraining already prepared models with your data, and it's really fast. It's
Yeah,
efficient and it's customizable.
cool.
So going back to data, what you can do with the data? You can filter it. You need to replace missing values, and then you can use normalizers. There are lots of options for that. For example, min max normalization. You can remove default stop words. So again, it depends on what kind of data you have, but you just need to make sure that your data is clean and is suitable for training. And then later on, when you train your machine learning model, and then you test it and you see that something is missing, or it's not performing correctly, then in a lot of cases, that's actually your data. So you can go back, clean it out, and update it or add more data if needed.
Mhm.
So now I want to move to ML.NET specifically. ML.NET actually is created for us .NET developers. When I saw it for the first time, I was really excited that I didn't need to learn Python or all those machine learning specific languages. I know Python is not used just for machine learning, but I know that lots of data scientists are using it, like
Yeah.
other languages like R, Python. Those are really popular. But now I don't have to learn them if I don't need to or I don't want to. I can use C sharp or F sharp, all my favorite tools to actually build machine learning models. ML.NET supports lots of scenarios. Some of them you can see here, like sentiment analysis, sales forecasting, object detection, and then you can also clean your data using ML.NET. All the stages of creating, training, and then using your ML.NET model, you can do it everything with just .NET, and that's exciting. Also, it is a open source. You can see it on GitHub. So here I have a link. There are samples there. You can see how it's working behind the scene. Also, I know that ML.NET is used behind the scene for some um, tools like Office tools and um, some other Microsoft software. So it is efficient, it is production ready, definitely. So you don't need to worry about ML.NET being relatively new to the public. Okay, we can go next to this slide. Here, I actually grabbed that diagram, that beautiful image of the process from Microsoft documentation. I keep telling people that the documentation that Microsoft is providing is amazing. If
Mhm.
you worked with other documentation, you have that comparison, and I definitely love all the options. The Learn, Microsoft Learn, where you can actually go and start creating something, learn something new, use practical skills to solve some basic challenges or some tasks, or actually the documentation, the samples. GitHub has lots of samples that you don't have to start from scratch. So I really like it.
Cool.
And going back to that beautiful picture that I have here, that's just a process how ML.NET is working, how it's being used for machine learning model development and then usage of that model. So initially, we need to collect and load data into iData view, and then create pipeline, then train the model. You can see that circle there. Once you train your model, you need to evaluate it. Make sure that it's working correctly, that is up to your standards. Sometimes your threshold can be lower. Depends on where you're planning to use your model. If it's something mission critical, like IoT solution, maybe it's a model for a health related software, then definitely it should be more accurate. For other type of software, it can be less accurate, and it's fine. It's totally up to you, and definitely relates to your project, what you're working on. So once you evaluate the model, you can either keep training it to make it more accurate. Maybe you need to add more data. Maybe you need to just change the data altogether if it doesn't work correctly. But if you're satisfied with the model that you created, then you can save it and use it right away. You are loading the model using that load method, and then you can make your predictions. So you are creating prediction engine and then using that predict method to get the prediction. Also, you can get not only the prediction itself, but also the level of confidence. So sometimes it can predict a result, but then the level of confidence is really low. So maybe you shouldn't use that result in your application.
Cool.
And then I want to move to Automl and ML.NET Model Builder. And that is amazing. I personally use it a lot because I don't have data science degree. I usually don't build anything too big, not using huge models. I am mostly a developer. I'm really interested in machine learning, but I'm not a data scientist. So AutoML is perfect for me. AutoML is not something specific to Microsoft. It is just that universal concept. It covers the complete pipeline from the raw data set to the deployable machine learning model. So lots of steps you can skip, and you don't need to think about going through lots of different model types and figuring out which one is better for your data. AutoML will do it for you.
Cool.
Yes, and Model Builder actually uses AutoML, and ML.NET Model Builder is integrated with Visual Studio. You don't need to do anything. You can just turn that feature on, or during the installation, you are just making sure that you are installing that feature. And that's it. It's already there. Really convenient to use it. Again, they have good documentation right inside Visual Studio, lots of links. You can go back to that GitHub account that I shared before, check samples there. Also, training models and modules and stuff like that is available for the model builder. There are two versions of the model builder, UI in Visual Studio, which I mentioned before, and also CLI. I personally like all the shiny, beautiful things in Visual Studio, so I definitely prefer the UI part. But I know there are lots of people out there who can't live without CLI, and that's totally fine. So you also have that option. ML.NET Model Builder has a limited amount of scenarios available comparing to ML.NET itself. But I think those scenarios, they are covering a lot of stuff that lots of people need, though everything that you might need is covered there. But obviously, if you need something extra, then you can skip the model builder tool and just use raw ML.NET and build your ML.NET model from scratch. So here you can see the scenarios. And also some limited scenarios available, like anomaly detection, forecasting, and clustering. They are limited. You can read about them, you can try them. I'm not sure that you can just go ahead and use them in production. I wouldn't recommend doing it. There are lots of changes coming and going, so it's still in a process, but it's just good to know what's coming and what ML.NET team is working on.
Cool.
And that's it.
So next week, we're going to get to the demo. We're going to see how to use Model Builder and build a model in Visual Studio. But I think this was a really nice introduction to AI and machine learning, particularly from a developer perspective. So I'm looking forward to diving in next week when we'll fire up Visual Studio and actually start doing this.
Thank you, Robert.
So I hope you enjoyed that and that you'll join us for parts 2 and 3. We will see you next time on Visual Studio Toolbox.